We're good to go. Okay, so what was that first homework question all about? Give me the radian measure of that first homework question. 4 pi over 3. 4 pi over 3. So you're going to be doing a lot of these all on your own in just a bit. So we have theta equals 4 pi over 3. I want to hear where that is. Who can describe for me where theta, which is equal to 4 pi over 3 is, with the terminology that I want to hear? You think you can? Raina, go ahead.
I was just going to say it's past pi.
How come it's past pi? Why?
Because it's an improper fraction. So that means it's more than 1.
Okay. So why wouldn't it be in quadrant 4 then? What are those words I want to hear? Think you know it, Jalen?
I was going to say it's in between pi and 3 pi over 2.
True, okay. Then, so those are good thoughts, and it's a good way for you to think about it if that's what you want to do, but those aren't the words I want to hear quite yet. Byron, did you have something? No? Thomas?
Oh, no.
Okay, I want to hear you say, Amy?
I'm just going to say that like 4 divided by 3 is less than 3 fractions.
And that's true. Okay, 4 divided by 3 is less than 3 divided by 2. So you're trying to tell me that, therefore, the angle measurement itself is going to be before here. Okay, and that's true. I want to hear you say that 4 pi over 3 is a little bit bigger than 3 pi over 3, which is just pi. So that means you're going past pi by just a little bit. So not measuring any angle measurements as far as degree goes or anything like that. I want you to think of 4 pi over 3 as being just a little bit past 3 pi over 3, which puts you into quadrant 3. Now if this had said 5 pi over 3, then your argument would still work. It's an improper fraction, so therefore you're past pi, but it wouldn't put me over here properly. If I had given you 5 pi over 3, which I know I didn't, okay, I know I didn't, 5 pi over 3 is almost 6 pi over 3, which is 2 pi. So instead of going all the way around, I'm just a little bit shy of going all the way around, and I would be in quadrant 4. That's the talk I want to hear. Okay, I want to hear you compare this fraction to either pi or 2 pi. Got me? All right. So let's go back to here. 3 pi over 3. So 4 pi over 3 is going to be down here. Can you tell me what my reference angle is quickly? What's my alpha? 60 degrees. How do you get that fast?
Because of the 3.
Well, that's not fast. 180 divided by 3. Okay? Take your 180 divided by 3, that gives you 60. Okay, 60 degree reference angle. 60 degrees, this is 90 degrees, so 60 is kind of big in here. Here's your 60 degree reference angle. I'm all the way over into quadrant 3 with my theta, which is 4 pi over 3. And this is a 60 degree reference angle. Now I need to pick a point on the what? The terminal side. I can pick any point I want on the terminal side and draw what? I'm going to go even bigger.
Perpendicular lines to the x-axis.
Draw a perpendicular line to the nearest x-axis. So, pick any point you want. I pick this one right here. I got to go perpendicular to the x-axis, which means, unfortunately, I'm going to push the x-axis over so I can see a little more of it. I'm going to go perpendicular to the x-axis. This way I have to go up. So perpendicular gives me a 90 degree angle. I have a 60 here. What's this one? 30. You should, off the top of your head, know the ratios of the sides of a 30, 60, 90 triangle. If you don't know them, you got to memorize them, okay? We've talked them through 2 different days. So what are they? 1, 2, square root of 3. What is the one side? Where does that go? Opposite the 30 degree angle. I go opposite the 30 degree angle, there's the one side. Where does the 2 side go? Hypotenuse. And the root 3 is the long leg. Got it?
Yes.
Now I have to add a little something to this. What do I have to add to these numbers, Thomas?
The square root 3 and the 1 both have to be negative.
Yeah, they both have to be negatives. Because not only did I go left from 0, 0, but I'm also going down. And that incorporates a negative sign. All right, from there, we're sailing, right? We have the sine of 4 pi over 3 geometric functions in order, right? I see some people, by the way, putting dashes down. Like they'll put a dash to say what the answer is. Don't put a dash, put an equal sign. Dashes look like what?
Negative.
Mine it says negatives. Yes?
Why is it two negatives?
The hypotenuse. Yeah, it's a good question. Sometimes things are just by definition, they're set that way. It's kind of like, it kind of reminds me of the definition of a prime number. What is a prime number? Yeah, it's a number that can only be divided by 1 in itself. Well, what about the number 1? Wouldn't that be prime?
Yeah.
No. Because in the definition of prime numbers, it says that a prime number is any number that only has itself and 1 as factors, with the exception of the number 1 itself. 1 is not prime. And it's in the definition. That's because when you hit some higher level mathematics, it matters. It doesn't matter to us right now. But with higher level mathematics, the number 1 just can't be prime, otherwise it blows other theories out of the water. So 1 is not a prime number. The very first prime number is the number 2. I'm surprised at that one. Yeah, 2 is the only prime number that happens to be even. All right, and 2 can only be broken down into 1 times 2. When I think of prime numbers, by the way, I know I'm off track, but it's a teachable second here. So 4 times 3 and 2 times 2 times 3. I'm doing prime factorization of the number 12. If 1 was prime, I would never end. Would I?
No.
I'd never end. So we got our prime numbers right here. Got it?
Gotcha, girl.
Gotcha, girl. Okay. Sine of 4 pi over 3. Remember where your perspective is. Where are you standing when you're asking that question? You're standing right here at that 60-degree angle, right at the origin. All the time you're at the origin. Got it? You're saying, hi, I'm over here. How you doing? You're opposite from me.
Now, would that reference angle always be 60 degrees or would it be
This reference angle is always going to be 60 because
With
it's
the
4
4
pi over 3. But if I had given you 7 pi over 6,
It could have been 30.
then that would be just a little bit bigger than 6 pi over 6, which would put me into quadrant 3 also by pi over 6. And that would be a 30-degree reference angle. Okay? And that's one of the biggest mistakes people make is they start dealing with triangles and they think every triangle now has to be a 30, 60, 90 now that I know what 30, 60, 90 means. Right? They think, oh, I've learned this one, now everyone in the world is going to be this one. But it's not. This is just a very particular triangle. Okay, sine 4 pi over 3. Negative root 3 over 2. We're here, we're comparing the opposite leg to the hypotenuse. Do I need to write SOHCAHTOA on the board? No. Anybody want it? I'll throw it up there. It ain't gonna hurt me. SOHCAHTOA. Okay? Nobody ever misspells TOA. T-O-A. Everybody does it right all the time. Some people swap the O and the A on sine and cosine. Don't do that. O comes first and then A. O comes first and then A. Maintain order. Order matters. Okay. Cosine. 4 pi over 3.
Negative 1/2.
Negative 1/2. Okay. What do you have? Tangent. 4 pi over 3. Okay, so it is a square root of 3. I'm going to write negative square root of 3 over negative 1. This is me showing my work, okay? And also, it's for anybody who says, how'd you get square root of 3? They can look and they can figure out how we got square root of 3. All right? We have what kind of functions here? Reciprocal functions. So I've done half my work and all I got to do is copy now. That's cheating though, isn't it?
No. Not really.
Okay. So what's the cotangent of 4 pi over 3?
Negative 1 over negative
Negative 1 over negative root 3, which would be
Root 3 over 3.
Yep.
1 over.
Okay. Turns positive first off, and you rationalize. And hopefully you can rationalize in your head. Secant 4 pi over 3? Negative 2. Cosecant 4 pi over 3?
Negative 2 root 3 over 2.
Over what?
Over 3.
Over 3. Anybody want to ask a question on this one? I gave you was theta is what?
11 pi over 6.
All right, it's going to go a little bit faster. Ready? 11 pi over 6. Well, raise your hand if you want to talk this one to me right. I think I did.
Wait, are you trying to say where it's at?
Yeah, I want to know where it's at. I want my terminology though. I want to hear what I'm trying to get you to get that concept of. Okay? I'm going to pick Byron right now. Go ahead.
Okay, so since 11 pi over 6 is just shy of 12 pi over 6, that means it has to be in quadrant 4.
Does that make sense? That's what I want you thinking, okay? 11 pi over 6 is almost 12 pi over 6, which is 2 pi. So it's almost at 2 pi. Put you in quadrant 4. Good job. What's my reference angle?
30 degrees.
30 degrees. How do you know it's 30 degrees?
180 divided by 6.
Because 180 divided by 6 is 30 degrees, which means my pi would have been chopped up into 30, 30, 30, 30, all the way around. And that would have been the little piece that I'm shy of the whole rotation by. All right? Now, if I gave you, I don't know, let me just think for a second. If I gave you 10 pi over 6, is my reference angle 30? No, because this isn't reduced, okay? The fraction needs to be reduced in order for you to identify your reference angle by doing that 180 divided by your denominator. What would this be? 5 pi over 3. So now you would do this division and you get your reference angle as what? 60 degrees. Okay? So only when the fraction's reduced, and I have no intentions of trying to mess you up and give you a fraction that's not reduced, okay? But I'm not saying you won't come across it someplace, maybe on an ACT or an SAT question. I don't know. So I'm at a 30-degree reference angle and I'm in quadrant 4. So that's not very big, okay? So 30 degrees is right here, and I'm in quadrant 4. What do I do now?
You pick a point on the
Pick a point on my terminal side.
and then you draw a perpendicular line to the nearest x-axis.
Good job. Say it again, Jada. Draw a line where?
Perpendicular to the x-axis.
Perpendicular to the x-axis. Pick a point on your terminal side. Remember, this whole thing is my theta. Theta is 11 pi over 6. And this in here is my alpha. Got it? So, pick a point on your terminal side and draw a line perpendicular to the closest x-axis. This has to be a what triangle? 30, 60, 90. Ratio of the sides?
1, 2, 3.
1, 2, and the square root of 3. Where does the 1 go? On the short leg, across from the 30-degree angle. So here's your 30, there's your 1, where's your 2? On the hypotenuse, and this here is long leg root 3. Okay. You know, I think, who was it? Maya, was it you that asked me why the 2 over here wasn't negative? Who was that? Santasia did? Okay. So that's just by definition. We always let that hypotenuse be positive no matter where we are. One of the other things I could say to you is that when you square this leg and you square this leg and you add them up, you get the hypotenuse. So you get the hypotenuse squared. You'd have to square root, wouldn't you? Square this, what do you get? Square this, what do you get? 1. Square this, what do you get? 3. Add that up, you get 4. What's the square root of 4? 2, not negative 2. Okay? But I don't know if that's a really good explanation, because we've always been told that if you're going to measure a side of something, it's got to be positive, not a negative length, right? We've always been told we don't have negative lengths. The negative in this case are x, y coordinates, and they only refer to direction. So by definition, the radius of the circle is always positive, period, no matter where you're headed around your circle. Right? I don't know, you know I don't really have a circle here, but that's the idea. Okay, so sine of what?
11 pi over
11 pi over 6. 11 pi over 6 again. 11 pi over 6 again. Cotangent, secant, and yeah, a little funky right there. Cosecant. Give me so let's go around the room. Want to do that? I'll start with you.
That way.
Sine of 11 pi over 6. Oh, am I missing anything?
Yes.
I am. What am I missing?
Negative one.
A negative on the 1, right?
Oh,
You were about to ask it? I wish you would have. I wish I had not said it. I wish I'd given you an opportunity to say it. Okay. Is the square root of 3 negative also?
No.
No. Okay. Sine 11 pi over 6. Go. Negative 1 half. It's up to you, Kara. Cosine 11 pi over 6. Square root of 3 over 2. Good job. Data.
Negative square root of 3 over 3.
Negative square root of 3 over 3. I'll take it. So she rationalized already, right? It was negative 1 over the square root of 3. Rationalized.
Negative square root of 3.
Just negative square root of 3. I could take over 1 and we'll just rationalize it. We'll just simplify it and leave it the way it is. Okay? Sienna?
Is it 2 root 3 over 3?
I believe it is. It's 2 root 3 divided by 3. Bless you, bless you. Brandon? Or Byron? I don't know where Brandon came from, sorry. Negative 2. Don't you feel insulted that somebody has to tell you what the answer is? I got this on my. Okay. These right here are what? Reciprocal functions, okay? So once you have, the first 3, it's like by 3, you get 3 free. All right. One more thing before I forget about it, I want to mention to you. The sine function, so if I took the sine of 11 pi over 6, which is negative 1 half, and I divided it by the cosine of 11 pi over 6, which is what? Square root of 3 over 2. What do you think this answer is?
Negative root 3 over 3.
It is. It is. I heard Jada. Did you hear Jada? Okay. First off, I have a fraction divided by a fraction. That's called an improper. That's called a complex fraction. So I want to get rid of the complex part of this complex fraction. I could literally write it out, negative 1 half divided by square root of 3 over 2, and then multiply by the reciprocal of my answer, my fraction that I'm divided by. I'm going to go like this. I'm going to multiply both top and bottom of that fraction by 2. When I multiply by 2 over 2, I'm really multiplying by the number 1, which is going to change the appearance of this answer, but not the value. Okay? 2's divide off. 1's are in the places. I get negative 1 on the top and a square root of 3 on the bottom. Rationalize that. Where's that? That is the same thing as the tangent of 11 pi over 6. So if you know the sine and cosine, you can always do the tangent by simply doing that division. Got me? Okay. Okay, so, any questions before I erase the board from anybody? No? We're going to begin our unit circle. Now, I asked at the beginning of the class how many people had seen or done the unit circle before in whatever classes you had before here. And quite a few of you said you did. Why is it called the unit circle? Anybody know? What? Don't mumble. If you want to say it loud and proud. What is it? Huh? I'm not hearing it. No one knows why it's called the unit circle? Thomas?
Some famous guy made it that way.
Some famous guy named Unit?
Yep. It's his circle.
It's his circle? Well, that's a possibility, I suppose. Okay. We have the unit circle the way it is because the radius of the circle is 1. 1 what? 1 unit. Okay? Whether your units happen to be inches or yards or centimeters or miles, it doesn't even matter. They just say a unit circle is a circle whose radius is 1 unit. A 6-inch circle would be a circle whose radius is 6 inches. A 1-foot circle would be a circle whose radius is 1 foot. This is a unit circle because the radius is exactly 1 unit. Doesn't matter what the measurement is, if there's just one of them. And the radius can be drawn all over this circle, right? The radius is always going to be a what? A 1, no matter where you are. Got it? I don't care where you draw the radius is a 1. So, let's see. Let's see. You tell me something here on this. Let's see where I want to go on this. Name that point. Name that point, everybody. Everybody, just say it.
1, 0.
0.
1, 0.
This is 0, 0. All right, this is indeed 1, 0. Okay. If this is the unit circle, then the radius brings me from the center of the circle over to the end, and that distance was a 1, and then I didn't go up and down at all, so it's just 1, 0. Name this point up here.
0, 1.
0, 1. Next one.
Negative 1, 0.
-1, 0. Sure am glad Daniel's here. 0, negative 1. These are known as your quadrantal angles. Anybody have an idea why they might be called quadrantal angles? They divide the quadrants, right? So they're right at the division between quadrant 1 and 4, or 1 and 2, or 2 and 3, or 3 and 4. But these points don't belong in any one particular quadrant. They kind of share. They're on the border of 2 different quadrants. So they're called quadrantal angles. That is the best purpose right there of the unit circle, in my eyes. Now, I really don't like the unit circle, and obviously I'm going on record saying that I don't really like the unit circle. But I like it for just those 4 points. Those 4 points are what I refer to the unit circle for. Basically, any other time, I never will. All right? But I do want you to be exposed to it. I want you to know where it came from. And maybe I shouldn't poison your thoughts on it a little bit, but I think there's easier ways to get things done. But I am going to entertain it with you. Okay? We're going to talk about the unit circle just briefly for a minute. We're going to build the unit circle. Yeah, we are. You don't think so? And it's easy. It's easy. Shame, shame, shame on anybody who ever just handed it to you and said, here you go, use it. Okay? No, we're on film here. What? You have it on a cheat sheet card? Cool. Okay.
Oh, I have one. Actual.
All right. So what goes on the unit circle, believe it or not, ends up being your 30, 60, 90, and your 45, 45, 90 triangles. So it's pretty simple. I'm gonna take the first one that comes to my mind. Which one's that?
30, 60.
30, 60, 90. I'm gonna start with a 30-degree angle right here, 30 degrees, and I'm gonna drop my perpendicular down like this, and I'm gonna mark the ratio of the sides on that 30, 60, 90 triangle. Okay? What goes right here? Square root of 3 goes there. That's called the long leg, okay? What goes on the hypotenuse? And what goes always across from the 30-degree angle? Okay, the 1. All right. So what I would like to do is take this 30, 60, 90 triangle and put it into my unit circle. Problem is, if I try to put that into my unit circle, I know perhaps this looks like a 2, but this is supposed to be a 1 here, right? And if I were to draw it, then this is supposed to be the length of 1 from here to here. 2 would be all the way out here, right? It doesn't fit in. So what do you suppose I could do to this triangle to fit it into, maybe I'll even convince you of it a little bit better if I drew it bigger. Okay? What can I do now to make this triangle fit into the unit circle where it belongs at a 30-degree reference angle right there?
What is that? You just make it smaller.
Make it smaller. Shrink it down, right? How much smaller do I need it to be? I need this hypotenuse to be a what? I need the hypotenuse to be the 1, because the hypotenuse of any triangle that's drawn inside your unit circle will be the radius of the circle. So the hypotenuse always has to be a 1. Now how am I going to make that become a 1? Divide by 2. Cut it in half. So I'm going to chop this thing in half. I'm going to actually divide by 2, and I'm going to end up with a smaller picture. Okay? Still a 30, 60, 90 triangle, but now this is a 1, because I divided this by 2. But if I divide one of the sides by 2,
We divide all.
Gotta divide all of them by 2. So this will be a 1/2, right? Maybe I shouldn't put it there. And what will this be?
Over 3 over 2.
Square root of 3 over 2. And now, this picture can fit perfectly into my unit circle. Where this short leg over here is a 1/2, this is a square root of 3 over 2, and the hypotenuse is a 1. Name this point for me, please. Square root of 3. Well, what's my x-coordinate again?
Oh,
Square root of 3 over
2.
2. And then my y-coordinate is 1/2. So that is the point, square root of 3 over 2, comma 1/2, and it occurs at the 30-degree reference angle, otherwise known as pi over 6. Now, instead of a 30-degree reference angle, I know you guys are writing things down, so I'm kind of giving you a little bit of wait time. Instead of a 30, maybe I'll switch to the other one in that triangle. What's that?
40.
In this triangle.
Oh,
60. Okay, so I want to draw it in such a way that my 60-degree angle is going to be going up. Okay, come back down. Here's my 60-degree angle. It's going to end up going up here. Got it? Now, I would really like to just erase what I have here. And you know, this is going to be on video, so you can like backtrack it and see it again anytime you want. So I think I will erase this. This is now going to, I'll leave the point there though. This is now going to be a 60-degree reference angle. And on my terminal side, from this point, I'm going to draw a line perpendicular to the closest x-axis. That gives me this triangle, which means my 30-degree angle is going to be up in that corner this time. What goes here?
2, 1.
Now, it has to be a 1 because it's on the unit circle. So let's go over here. And what goes on here typically? Typically it's a 2. Your one side is across from the 30. Your 2 is on the hypotenuse, and your long leg is a square root of 3. However, this picture will not fit inside my unit circle. I need to cut it in half again. So I'm going to divide it by 2. And when I do that, it's going to be upright like this. And instead of having a 2 here, it'll have a 1. What will be here?
1/2. Root 3 over 2.
Root of 3 over 2, and what's going to be here?
1/2.
Does it surprise you that all these did was turn around? The 1/2 and the root 3 over 2 just turn places? What used to be an x-coordinate is now going to be a y-coordinate. What used to be a y-coordinate is now going to be an x-coordinate. So give me the xy point right here.
1/2. Square root 3 over 2. What was
What was the what?
the point for the 690?
It's right here.
Oh.
Still sitting there. So this is your 60-degree reference angle, otherwise known as pi over 3, hopefully. Now the unit circle doesn't have these triangles drawn inside it. It just has these points going around it. But this is what the points represent. It represents the ratio of the sides of the 30, 60, 90 triangle and the 45, 45, 90 triangle. I am not going to do this in quadrant 2 or 3 or 4. You want the numbers in quadrant 2? Guess what you get to do? Flip them over. It's the same dumb triangle, right? You're just going to put it in quadrant 2. So what point do you think is going to be right there? Just take quadrant 2 and cut it up into 3 equal pieces. I want this one. Take this point, reflect it over here. Ooh, just negative 1/2. And then square root of 3 over 2. How about this point, right there? Negative square root of 3 over 2, comma, 1/2. It should just be reflected over. that unit circle right now as far as creating any more numbers on it. I do want to talk to you about a relationship that exists on the unit circle, which I think is pretty cool. And I'm going to use this 60 while I'm here. All right? The sine of 60 degrees. Look at your 60 triangle right there and tell me what the sine of 60 is. Sine compares the what to the what? Opposite to the hypotenuse. And if you're standing right here at 0, 0, let's not forget, that's always your perspective right there at home. Here, that's 60 degrees right here. The opposite would be your root 3 over 2. The hypotenuse would be your 1. So sine of 60 degrees would be the square root of 3 over 2 divided by 1, which is just square root of 3 over 2. This is why we do a unit circle, because we like to just have a 1 here and just be able to take our y coordinate. Do you notice that this is the y coordinate, it is the y coordinate right here of that point. What if I wanted the cosine of 60 degrees? You're right there at that value, right at 0, 0. Cosine compares the adjacent to the hypotenuse, which makes 1/2 compared to 1, which is just 1/2. Do you recognize that as being the x coordinate right over here? This is the y coordinate. So this is the cool thing about the unit circle. Anywhere on the unit circle, you get the cosine of the angle first as your x coordinate, and you get the sine of the angle second as your y coordinate. And now, this is why I love the unit circle. You ready? What's the sine of pi? Because I can't draw a co-reference triangle with a pi. Go to where pi is on your unit circle. Do you see it? I want the sine of pi. The sine of pi will be sitting right here in your y coordinate. So 0, right there, right? 0. That's it. No work to do for it. If I ask you to show me work, you go like this and you put a dot there. That's it. That's all I need. What is the cosine of 3 pi over 2?
0.
It is 0. Good job. If I ask you to show work, you just go like that. Because 3 pi over 2 is all the way around 3/4 of the circle. Okay, you go 1/2 pi, 2/2 pi, 3/2 pi. All right? That's going to catch us, but I am going to hand you a homework on your way out the door, okay? And the directions are there. Michaela, would you mind timing out? Talent out. You guys want to help me with that? 1, 2, 3. Talent out.